Hi, everybody. Okay, today we're going to go over correlation method. There are first these two other vocab words that we need to discuss as well. So there's a difference. Another confusing pair is going to be longitudinal studies and also cross-sectional studies. So the difference between this pair is that a psychologist for a longitudinal study is going to study the same group of people over a very long period of time. So hence longitudinal studies. So this is basically studying someone when they're born, when they're 5, when they're 10, when they're 15, when they're 20, when they're 25. So these studies are awesome because you get to see development all the way from when they're little all the way into adulthood, and you're able to stay with the same group of people consistently. It's not the easiest task to do because sometimes you can lose participants of where they've gone in their lives and they may not come back to do the rest of the study. So when you do get a chance to do this, it actually provides a lot of valuable information. Okay, a cross-sectional study is different because it's not about a long period of time. It's about cross data between different types of groups. So it's essentially, for example, you're studying different types of groups, but simultaneously. So if I wanted to study academic motivation in high school, I would then study all 4 levels, freshmen, sophomore, junior, seniors, at the exact same time. So it's kind of like a snapshot. And so at the exact same time, I'm studying all 4 of these levels. And so it's basically going to cross-sectional the information. So I'm going to assume usually motivation after spring break is very low for seniors because they're almost done. It's the end of the school year. And so that could be an example of a cross-sectional study. Okay, moving on to today's main lecture is going to be a correlation method. So correlation method is awesome. It tends to be most confused with experimentation, which is totally not the same thing. So correlation is never causation. When it comes to correlation, it's basically when one behavior or behavior accompanies another, we say the two are correlated. And so other keywords is prediction and relation. So correlation coefficient is essentially this number, okay? It's going to be the R equals whatever number. The number itself, regardless of plus or negative, is how strong the relationship is. So the higher it is to 1, you can't go over it because that doesn't exist, the stronger the 2 variables are related. Okay, the plus or negative sign is representing the direction of the relationship, telling you whether it's a positive correlation or a negative correlation. Okay, so definition of correlation method is how 2 or more variables are either related to each other or how they can predict each other. So you're either going to have a positive correlation or a negative where one goes up and the other goes down, which we'll get to. Okay, so the good things about correlation method is the fact that you can observe, not observe, but you can collect data from outside the lab, so it doesn't necessarily require an experiment. Also, you can actually replicate a correlation. Your go-to answer for limitations is going to be no causal. Okay, you cannot manipulate any of the variables. So when it comes to correlation coefficient, which is your R, okay, the key number is 1, whether it's positive or negative. The closer it is to 1, the stronger the 2 variables are connected or related or correlated with each other. Anything over 1 doesn't exist. So this one is telling you plus or negative which direction the 2 variables are correlated with each other. So again, the stronger it is to 1, excuse me, sorry, the stronger the relationship. Okay, so a common question on the multiple choice exam is I'll do this. Let's see, 60.62, negative 1.25, negative 0.67, and then 0.25. Okay, a question like this would basically say, okay, out of these 4 numbers, which one is the strongest relationship? Okay, the answer would be this one. Although 0.62 is good because over half, it's still not closest to 1. Negative 1.25 doesn't exist because it went over 1. Negative 0.67 is the closest number to 1, regardless of the plus or negative sign. and then 0.25 is low. So this one is the number that is closest to 1, and so that's why it has the strongest relationship. Okay. So then a positive and negative correlation is nothing to do with bad or good. We're not talking about bad, good, negative. It's just about which direction are the two variables related. So basically, as one variable increases, the other is also going to increase. So for example, my two variables that I'm trying to study is hours of studying and your GPA. Those are your two variables. So ideally, it'd be considered a positive correlation. As one goes up, the other goes up. As one goes down, the other goes down. So ideally, the more you study, the higher your GPA. Or the less you study, the lower your GPA. Okay. Let's think. Sorry, let's go back. So think for yourself, what are some other examples of positive correlations where the two variables go in the same direction, up or down? So another one can be, I'm trying to think. Okay, the more sleep you get, the more, the happier you are in the morning. Okay, the less sleep you get, the less happy you are. Okay, so the two variables are going in the same direction. Okay, a negative correlation is they're going to go the opposite direction. As one variable increases, the other is going to decrease. For example, the more you watch TV, the lower your GPA. Okay. Another one can be, let me think. Let's see. The more you exercise, the less body fat you have. Okay, if I was to say the more you exercise, the more you lose weight, this now becomes a positive correlation. But if you word it like the more you exercise, the lower body fat, that now becomes a negative correlation because it's going the opposite. Okay, so a lot of times it sounds so clear cut, right? Like, well, duh, of course you exercise, you're going to lose weight, blah, blah, blah. Or, of course, the more you study, the higher GPA. So although sometimes it seems so clear cut, a lot of times you cannot say cause and effect because we actually didn't do anything to manipulate the variables. So there's also other things that could be happening, okay? So it can also go the other way. So for example, we could say, sure, the more you study, the higher GPA, but what if it was the opposite way? So maybe it was because you have a high GPA, that's why you study. So for example, TV watching could be a cause of GPA, or because you have a low GPA, you do more TV watching. So that's why you can't say cause and effect. They're correlated, but you cannot say one causes the other because we don't know which direction it's going in. Or maybe there's this whole other thing that's contributing to the low GPA. Maybe it's not even TV watching or time spent studying. Maybe simply because it's low intellect, low intelligence, and that's what's correlating with the low GPA and a lot of the TV watching. So this whole third issue is called a confounding variable. So you can call it three things: a confounding variable, an extraneous, I can spell that, extraneous, it's really hard to do that on this thing, okay? Extraneous, so this looks like extra. This extra thing that's happening, or it can also be called a third variable, okay? All three of these words are used the same. Confounding variable, extraneous variable, third factor basically means that we cannot say cause and effect because there can be this other thing that's floating that is creating the data that we're getting, okay? So here's an example. The length of marriage is correlated with male baldness. Okay, so it's basically saying the longer you're married, the more likely you're to be bald. But can we say that marriage causes baldness? No, because there's a lot of married men that are not bald, and then there's a lot of unmarried men that are bald. And so you want to consider what other factors, what confounding, extraneous, third factors could be contributing to male baldness. One, it can be genetics. Okay. I don't know if you guys know this, but the theory is that baldness in men isn't necessarily about your dad. It's about your mom's dad. So basically your grandpa on your mom's side. So if your grandpa on your mom's side still has his hair, that means you have a higher chance of basically having your hair as well. Okay, it could also be stress. Okay, stress can definitely contribute to male baldness. Also, it can be your diet. Okay. Or diet. It can maybe be some other disease or illness that you've had that has basically contributed to your baldness. So that's why you can't just say, oh, the longer you're married, marriage causes baldness, because you have all these other extraneous confounding variables that could be contributing to the cause. Okay? So when you're looking at scatter plots, so scatter plots is also used to basically plot data. And so it's going to show you the slope of the direction and then the amount and strength of the relationship. So this is a perfect positive. It is going in a positive way. All the dots are together. So you can tell it's a perfect one correlation. Okay, this one is a perfect negative. This one has no relationship because the dots aren't close together at all and there's no specific direction. So there's no relationship in this specific data. Okay, so again, perfect positive, none, and perfect negative. I'm going to skip that. Okay, this one, if you're looking at it, it's saying that they're trying to find a relationship between height and temperament in people. So maybe the taller you are, the difference of the higher your temperament. So this one, just looking at the dots, you can tell it is going in a positive manner because they're scattered that way. They're not tightly knit together, but they're kind of close. So then this then would be about a 0.63 correlation. Not the highest, not the lowest. It is above, it's over half. So it's a decent correlation. Okay. So again, understanding that correlation is not causation. So some people would say, oh, well, low self-esteem causes depression. Okay, we can't say that because what if they already have depression and depression is what's causing the low self-esteem? Or maybe it's none of those. Maybe some other event like a death of a loved one, an illness, a biological disposition, brain chemistry that is actually contributing to both low self-esteem and depression. So that's why we can never say that correlation is causation. They're correlated, they're related, and they can predict each other, but we can't say one causes the other. Okay. So there's something also called illusory correlation. So this basically looks like an illusion. Illusion is something that's not there, that's not real. So it's the perception of a relationship where there's actually no relationship that exists. So in this example in the book, it basically was saying that they were trying to find a correlation that usually people that can't have children, once they adopt a child, then they're more likely than to have a natural one between them and their partner. And so if you're looking at it, that's not actually correlated. There's so many other factors to it, so there's no causation. Another illusory correlation is that some people think that when there's a full moon, bad things happen. There happens to supposedly be more, arrests or phone calls or people suffering and trying to call their therapist and that kind of stuff when there's a full moon. Okay, that's not actually correlated, but people assume that. Or also like on Friday the 13th, people assume that there's a lot of bad luck on that day, but there's no causation, there's no proof. So that just happens to be like an illusion. Okay, so last thing, correlation does not mean causation ever. And that is going to be your go-to answer for a limitation on an FRQ. Okay, and then let me see. Okay, I'm going to post another. Actually, you know what? Maybe I can still do it in here. Actually, no. I'll post another link for the homework assignment. The worksheet is going to be in Canvas. And then I'll go over this with you guys on Monday again over the answers. And we can talk about it if you have any questions.